I changes FinOps because spend is tied not only to usage but also to behavior, quality, and outcomes. In this topic, we'll connect cost visibility, usage optimization, and shared accountability to the realities of LLM workflows and autonomous agents. So far, we've seen why agentic AI is harder to manage than traditional cloud workloads. Costs shift with variable paths, tool calls, tokens, retries, and autonomy. Now we apply FinOps discipline, visibility, optimization, accountability, and controls. The goal is a shared operating model that connects AI spend to ownership, value, and eventually quality. Traditional FinOps worked well when usage was mostly predictable: compute, storage, and steady utilization patterns. AI changes that equation. A single request can expand into prompts, tokens, embeddings, vector searches, tool calls, retries, and model choices. Cost is no longer just infrastructure consumption. It is tied to system behavior and business outcomes. The goal is not simply to spend less. It is to choose the right model, control unnecessary work, and preserve quality, latency, safety, and user value while making spend visible and accountable. FinOps still works for agentic AI, but the inputs change. In the inform phase, visibility has to go beyond cloud spend. Teams need telemetry for tokens, model choices, tool calls, workflow paths, and attribution by product, team, or customer. Optimize uses that visibility to reduce waste through model selection, prompt improvement, caching, request routing, batching, and context control. Operate makes the practices durable through budgets, alerts, policies, owners, and review cadences. Because agents, prompts, models, and usage patterns keep changing, this loop never really stops. Inform is where AI FinOps becomes measurable. Instead of treating AI spend as one monthly bill, teams capture the signals behind it: tokens in and out, model calls, embeddings, vector queries, and tool use. They then tag that activity to the right owner, such as product, workflow, environment, agent, or team. The real value comes from connecting usage to outcomes. Did the support agent resolve more cases? Did analysts save time? A good dashboard combines cost, usage, performance, and quality, so optimization decisions are based on evidence rather than guesswork. Cost attribution starts by collecting every AI usage event, not just the model call. Inference, embeddings, fine-tuning, image, speech, and platform fees are direct costs. Agentic systems also create spend through vector stores, orchestration, observability, compute, serverless functions, and external APIs. The allocation engine connects those charges to metadata: agent, workflow, tenant, product, environment, cost center, and owner. That context changes the conversation from AI costs are rising to this workflow for this product owned by this team costs this much to deliver that outcome. Optimization begins with a practical question: what is the least expensive way to meet the required outcome safely? Sometimes that means a smaller model. Sometimes it means paying for a stronger model because failure is more expensive. From there, reduce waste, compress prompts, prune context, cap response length, cache repeated answers, and detect duplicate requests. For agents, also control behavior by avoiding endless loops, excessive retries, unnecessary tool calls, and overly broad retrieval. The key is measurement. Every saving should be checked against quality, latency, reliability, and risk, not cost alone. Operate is where AI FinOps becomes routine, not a quarterly cleanup exercise. Teams monitor usage and cost every week, while budget alerts and anomaly detection flag problems early: a token spike, rising cost per task, or unusual agent behavior. When something triggers, the workflow moves to investigation and approval. Who has access? What limits apply? Should deployment continue? Monthly value reviews connect spend to business outcomes, and quarterly model reviews revisit strategy. The loop closes when insights drive prompt changes, model routing, product design, and capacity planning. Total AI spend is useful but too blunt for decision-making. Unit economics turns spend into measures tied to real work: cost per task, conversation, workflow, transaction, or outcome. This matters for agents because a simple request can trigger planning, tool calls, retries, memory lookups, and model handoffs behind the scenes. The right unit lets teams compare agents, models, vendors, and optimization choices fairly. Consistency is critical. Define what costs are included and define what counts as success. Otherwise, the metric may look precise but lead to the wrong decision. Unit cost only becomes useful when the unit matches the work. For a simple summarizer or code assistant, cost per task may be enough. Total AI cost divided by completed outputs. In support, cost per conversation captures the full chain of model calls, retrieval, tools, and routing across one customer interaction. For agents, cost per workflow is often better because planning, validation, and tool use can span many steps. For executives, cost per business transaction connects AI spend to outcomes like claims, applications, purchases, or resolutions. Always include direct model costs plus relevant indirect orchestration and infrastructure costs. Cost per request tells you what one interaction costs. Cost per successful outcome tells you what the business actually paid to get a useful result. Imagine Model A costs 3 cents per request but succeeds only 60% of the time. Its cost per success is 5 cents. Model B costs 7 cents per request but succeeds 90% of the time, so each success costs about 8 cents. Sometimes A is still cheaper. But if failures create escalations, rework, risk, or unhappy customers, the outcome metric reveals the real economics. AI FinOps works only when accountability is distributed. Finance brings budget discipline, forecasting, chargeback, and value analysis. But it cannot explain every token spike or agent behavior. Platform engineering creates the shared foundation: telemetry, controls, policies, and reusable guardrails. AI engineering makes the technical choices that drive cost, including model selection, prompt design, evaluation, orchestration, and optimization. Product teams connect spending to user value. Security, compliance, and governance keep the system within acceptable risk. The operating model succeeds when these groups share one feedback loop, so cost, performance, value, and risk are managed together. AI FinOps decisions break down when everyone has input, but no one owns the call. RACI fixes that. Responsible means the team doing the work. Accountable means the single person who ultimately approves the outcome. Consulted groups provide expertise before the decision, and informed groups get updates after. For example, product may be accountable for customer impact, engineering responsible for implementation, finance consulted on budget, and governance consulted on policy. Use this for model onboarding, budget approvals, prompt changes, agent launches, and anomaly response. The goal is faster action with fewer gaps, duplicates, and orphaned costs. An AI FinOps operating model starts with knowing what exists: applications, agents, models, workflows, owners, and the business purpose behind each one. With that inventory in place, teams can measure consistently across cost, usage, quality, latency, risk, and outcomes. Those metrics then feed controls such as budgets, policies, deployment gates, anomaly alerts, and review forums. The goal is not bureaucracy. It is shared accountability. Over time, the model matures from basic visibility into automated optimization, where policy-driven decisions keep AI spending efficient and aligned to value. The core message is simple. FinOps still works for AI, but the measures and decisions must evolve. Inform creates visibility, optimize improves efficiency, and operate builds accountability. Track costs by real units of value, such as tasks, workflows, and outcomes. Treat cost decisions as shared governance decisions, balancing spend with reliability, safety, risk, and user value. Next, that balance becomes governance.